upon descent.
Hey, what's going on, everybody? How are you doing? Happy Sunday, everybody. Hope you guys are doing super good today. Happy Monday, if it's already Monday for you, wherever you may be. Hope you guys are doing super good. We are going to get back into our Kerbal, our KSP, our Kerbal Space Program, guidance, navigation, and control programming. We have Python that we're writing in order to automate all of our rockets in KSP. And we're going to continue that development that we hit off with yesterday. So before we do that, though, if you guys missed it, there was an excellent launch this morning from Blue Origin for their New Shepard vehicle. This was New Shepard, the 25th flight. This one was carrying people. Yeah, we have a new record for oldest person in space, which is actually pretty awesome. Ed Dwight. It was a good launch, chat. It was a good morning. Unfortunately, it was delayed by like almost an hour, which was kind of unfortunate, but hey, that's how these things go. But yeah, vehicle took off and landed. We have our new Blue Origin system with the improvements made to their propulsion system after the unfortunate incident of NS-23, which was 2 missions ago. Yeah, the propulsion system popped, for lack of a better word. Quite literally popped. Like, you can quite literally see it on camera just go poof, and it was no longer in existence, the engine down here. But of course, the abort sequence activated, carrying the capsule to safely. All was good. There was no people on NS-23. Which is also a good thing. It was just carrying some scientific experiments. But yeah, so let's just click through and see a replay here of today's launch. It was quite good.
To make sure it ends up right on its landing pad 2 miles north of where it's taken off from.
So carrying, I believe, 6 people on this flight. It was a full flight. Above the Kármán line, I think they hit like an apogee of like 347,000 feet, which is just over 100 kilometers. Yo, what's up, Thomas? How are you?
All right. Final countdown. Let's turn it over to mission control.
T-minus 10.
Let's light this candle.
And with Blue Origin, they ignite
6,
at 0
5,
and then launch
4,
at 7.
Command engine start. 2, 1, 0. Ignition. And liftoff.
And then we should be at, yep, T plus 7 seconds or so when it actually releases.
New Shepard has cleared the tower.
Happy that NS-25 went today. Truly, it was very nice.
Up to space.
Quite the launch.
Now you can follow along on the bottom left of your screen. The altimeter on the left. Excuse me, altimeter on the right and the speedometer on the left.
Altimeter on the right and speedometer on the left. No, I think you were... Oh, I see. She's talking about this. Thought you're talking about the entire screen. I was like, no, it's on the left side. So yeah, we have a successful return to flight for the New Shepard vehicle for carrying crew. Now they did do a previous mission after that failed mission. NS-24, but that wasn't carrying people on it. So this was the first return to flight for crew. Vehicle, it's sort of concept of operations from here on out. Is this going to get into its coast phase? I think it shuts down its engine somewhere around 2 minutes. And then from there, it enters coast phase. Essentially, at that point, the capsule will separate to return back under its own parachutes for safe landing. The booster will come scream here, slowing itself down and guiding itself back to the landing pad, and then from there making a propulsive landing.
So far, a nominal flight. We have gone through max
Same tail to
Q.
have flown the RTF, though. Also the first tail to hit 10 flights. That's awesome. I was wondering about the tails. Have they, are they producing, or have they already produced a replacement tail? Or are they only going to go with this one tail? I mean, I'm sure they're in the middle of the development of the other tail after losing one. I don't feel like it's I don't feel like it's very smart to only be operating with one tail, because if you lose that one for whatever, who knows what happens, you know, you're then out of flight.
Miko.
There's Miko.
There we go. Main engine
2.5 minutes into flight,
confirmed.
then we should have capsule separation.
Passing 200,000 feet.
Now with the main engine cut off, with
They haven't used it yet? Gotcha. So they already have one, though.
The E3 engine turned off. The vehicle continues to climb up towards its apogee, but as you will see on the left side, the speedometer will come down, and once that speedometer hits 0, that's when you know exactly that the vehicle has hit apogee, its highest altitude in the flight of the vehicle. Now I understand that separation of the capsule from the
gotcha,
booster
Thomas.
has
Okay.
been confirmed. And
All right, so you can
0G
actually
has
see on the camera
started
here,
for
that's the
our
capsule.
astronauts.
It's already been, it's already separated from the tail, what they call the tail. It's essentially the first stage. They call it the tail, though.
The beauty of floating around in 0G, but of course, the spectacular views out of those.
I was a little sad that we didn't get any internal views of the astronauts. I know that's not common, but they have done it.
Having passed over 330,000 feet, they are over the Kármán line, so welcome to space, astronauts.
So yeah, passing 100 kilometers. Still cruising on up. The tail should essentially be just about returning itself. So there we go, 347,450 feet.
347,000 feet or so. Of course, we'll confirm our official figure at the end or after the webcast.
New Shepard propulsion module, there you go. There you go. So yeah, now they are all returning. They're still in 0G. They still have a little bit more time here where the astronauts inside the capsule can move about freely. But they are pretty much going to have to start buckling back into their seats here very, very soon.
Our astronauts are still enjoying that beautiful 0G up in their capsule. All 6 crew just officially became astronauts. So exciting. Now, thank you again for joining us for the 25th mission of New Shepard, our 7th human flight.
So now the booster and everything is on its return. What we'll actually see on the booster is at the very top of the vehicle, they have deployable fins. And they're quite literally like pizza slices or wedges that just come outward. They're static. They don't actually move except for deploying. And it's just basically to improve the stability of the rocket as it's coming back through the atmosphere. And then once they get back in the atmosphere and they're going about Mach 1, maybe like slightly less than Mach 1, they deploy what are actual deployable speed brakes. So you'll see those pop out of the booster as well once it gets closer to the ground.
Speed up back towards Earth.
I don't know, Misadventures. I haven't seen any, but I didn't look recently.
More aerodynamically shaped. And once it hits atmosphere, we've got a multitude of.
Is this picture from the booster or the capsule?
Landing pad just 2 miles north.
I feel like it's the capsule since it's rotating, and I don't think the booster should be rotating.
The crew capsule.
But I don't know where this camera would be.
Down into that West Texas
Actually, the booster
Valley
might be rotating.
for a nice soft landing.
I just like to know what camera this is. It must be the booster. It's falling pretty fast. Oh, no. See how it's like kind of like doing this? It does look more like a capsule dynamics. So there's the actual wedge fins that are deployed here. That's what they call it here, wedge fins. They're at the very, very top. They weren't there before. They deploy outward. They are static. And then we should see pretty much in the next few seconds, the drag brakes will deploy as well. Pretty much, very much like in KSP, they are just big control surfaces that deploy outward, creating a whole bunch of drag at the top of the vehicle, help slow things down, keep it stable. There they go.
That is headed down. You see the drag
Those are the drag brakes.
The drag brakes that have just deployed.
It is on the ring fin. Okay, so it was the booster. Cool.
Booster in half. Also at the top of the rocket there, you see the forward fins. They kind of look like pie slices, one on each quadrant.
There's engine start for landing.
There we go. BE3 engine relight.
Oh, it's so good, chat. And this thing is small enough, right, where it will actually enter a hover before landing, just like our DCX vehicle. See, there it is. Enters a hover, enters a velocity gate, and then it starts descending.
50 feet, 8 feet per second.
Yeah, Thomas, indeed. If you have a time stamp for that, I'd love to show that, but I don't remember where that was. Was it? No, not there.
What a
Not
beautiful
there.
flight to space and back.
Wasn't it
for that
early?
booster. Man, it feels good to
That's
be
all
flying
New
again,
Shepard.
Jackie.
No,
Taking our
must have been
astronauts
after.
to space and back. It is.
That's the pinning.
Every day is a good day at the
Yeah, I'm not
rocket
sure.
factory, but flying.
But there you go.
people
There's the
never
tail, the
get
booster,
old.
back again.
And I love that
10
once
flights
there's
under this one.
dust that gets kicked up, and it's once it clears a landed booster. It's
Claps
like a
and
magic trick.
claps. Indeed. Really excited for this.
Booster just
Like, I'm really
arrived.
glad
Yeah,
New
it
Shepard is
definitely
back to
adds
flight.
To the drama of a landing a rocket.
Around T
from
minus
space.
16. Okay.
And
So that was a
really
good, successful landing of the tail.
This is really one of the proudest
Now, what we
moments
should
because
see
it
here
shows
soon is the capsule
the
come into
incredible
camera view.
engineering. It
Now,
is
what's
magic.
interesting is the
It is
capsule
not
actually had a
Jackie.
parachute that did
The
not
engineering that has
unreef.
gone into
But
bringing
it's important to note that that is
design
totally
and testing
fine.
and flying, but bringing this rocket home
Not
from
necessarily
space,
nominal,
ready
but
to be
totally fine.
reused. You see very
So that was
quickly
kind of
that
interesting.
The forward fins come back in. The
Yep,
drag
forward fins
brakes
have
come back
all
in. You look like
retracted.
you just fuel her up
So
and
there's the
launch her from
capsule
there,
under
and ready to go
parachutes.
again. But the show is not over. The crew capsule has deployed its
Once they
guide
zoom out, you'll see what I'm talking
and
about.
its mains. Everything looking nominal on today's flight.
Almost nominal. Almost perfectly nominal. See, there you go. So on this, we have two very good main primary parachutes. And the capsule does have 3. But as you can see on this one failed to inflate. And it looks like it's still reefed. What that essentially means is because the capsule and the parachutes deploy at very, very high velocities, you don't want them, like in KSP, to just go from like doing nothing to full inflation, because that would, you know, snap everything, massive loads on everything, the capsule, the people in the capsule. You don't want to do that, right? So essentially they have a you know, some sort of tie literally around the bottom of the parachute to keep it kind of from fully inflating, partial inflation like you see here. And then there's actually like a timer or a barometric pressure, something along those lines that senses the time it's been deployed to then cut that line and then open the parachute fully to allow the parachute to inflate fully. So we have 2 good mains here. This one looks like it's still reefed or just never fully inflated. Again, the capsule is fully designed to be able to land under 2 parachutes. That is fine. But yeah, kind of like an off nominal landing configuration, which is kind of interesting. Doesn't seem like we got a complete list of what they found. Misadventures, the only thing that we really know is that the design of their propulsion system, the BE3, that's the primary engine on the first stage, right, on the booster. After however many subsequent flights and things they had, it entered into a state of having hot streaks in the engine based on their cooling system design. And so the primary fixes that they made was essentially redesigning the engine a little bit, not like a full redesign, but redesigning some of the combustion chamber to allow to try and mitigate those hot streaks from occurring. It was primarily things like that that as far as I remember, it's been a few months since we got the full spiel. I'm sure it's within range to land with 1. I don't think it can land with 1. I think that'd be pretty rough. But it can definitely land under 2.
Looks like we do have 2 parachutes that have full inflation. The third is not quite fully inflated. But actually, Jackie, this is
Yeah, exactly. Like, it can. It's not going to be great.
In fact, we were talking about my first webcast.
It's certified for 2.
The first webcast that we did,
You don't want to enter
shoot out.
non-certified flight, right? Because then that's unknown behavior.
In this system, and so landing with 2 parachutes is perfectly okay for this system. You'll also see the dust take out of the base.
This thing has retro rockets too, which is pretty cool, like Soyuz.
He comes into land. That is the air cushioning system. It's going to kick up a lot of that West Texas dust you just talked about.
There you go.
But it also, there it is, touchdown of the crew capsule.
Yep, it has retro thrusters like Soyuz.
A beautiful flight. For
There you go,
our
chat.
rocket, for our
All
crew capsule
nominal.
Experience.
Vehicle landed, crew safe and sound.
I know this is a hard
Here's
question.
the recovery
One
operations.
highlight from the flight itself.
Ed Dwight, that's right, finally an astronaut.
But there's so many really interesting things.
Which you might want to consider if you should, exactly. We were too busy. You were too busy wondering if you could, that you never asked yourself if you should, right?
I felt almost like
And then here's their
While
egress.
he did
There.
not get to fly
Heck
then,
yeah.
Today was his opportunity.
See the step out. Look at him.
And
Oh, the
here
beast.
exits Ed Dwight.
Ed Dwight, now the oldest
This
person in
gentleman has
space.
waited a long time to go to space.
That's awesome.
Selected in the early 60s as the first black astronaut to fly, although he did not get to fly then. Today
Sweet.
was his
So there was one thing that
opportunity,
Thomas
and man,
mentioned. He
what
gave me a
flight was that.
timestamp that they showed
Finally, an official astronaut.
some New Glenn updates or like footage from something the size of a bus to something the size of a skyscraper. You know, it's fine.
So very recently, as you see here on your screen,
A tall building
rolled out New Glenn
that we're launching versus just a
very
bus-sized
And
vehicle.
this milestone was the first in a
Look
series
at that
of
though. Oh, I can't wait for New Glenn, chat. I'm so excited. We're going to be building New Glenn. We actually already have the New Glenn first stage in KSP. But this is kind of what I want to, if we can get our GNC fully functional, I want to get New Glenn back in KSP. That's what oh, it's such a good looking vehicle though.
test in preparation for
Do they
New
have the
Glenn's
next
first
crew
launch
flight
later
scheduled? I don't know. I don't think we have a specific schedule for it
allowed
now.
our teams to test flight
Yeah, the
hardware
transporter
and
vector
ground
is super
software
beefy.
and practice launch operations, which
Oh yeah, they lifted it.
Jackie, I'm
Yeah,
sure we'll talk
full
about
pad
the
checks they
design
performed
of
with
the
the
rocket, et
structural
cetera.
test article.
But the operations part of it is just as important, and that's why this was a crucial now, as you can
So
see here,
nice.
New Glenn, in a word,
New
I would
Glenn.
say is massive. Right? You know, we're talking
Massive.
5 times the size of New Shepard. You know, over 300 feet tall.
Yeah, you know,
It's over 100 meters.
it's only a
tall.
30-story building.
And there's a lot of similarities, let's say.
I know, right, Captain
between
Failure?
Shepard and New Glenn, more so
Ah,
than
it just
New
looks so good. I can't
Yes,
wait, man.
Right. For example,
45 metric tons to
vertical
LEO,
systems, the fin
roughly.
systems
I
are
mean, that's their
similar.
current
But
analysis
also,
that's
there are things
public,
that
but
aren't quite as visual.
could be better than
So
that, could be a
software
little worse,
systems,
but that's
internal
their
propellant
design
tank
point.
designs, and like you
45
mentioned,
metric
Ariane,
tons, chat. That's wild. Okay, that's absolutely crazy. 45 metric tons. I mean, think about it. That's a single stick rocket, single stick booster that's essentially capable of what Falcon Heavy is with 3. Like, that's pretty amazing.
It
7-meter
shows
diameter, I think that's
experience
right.
that we're gaining on New Shepard helps us build confidence in New Glenn's future success. Truly, every time we fly New Shepard, it helps our team learn how to make
Oh, yeah.
human space.
That's a little update. We got the full footage there of their
for the very first time.
transporter
And this
rector
milestone was
testing, their
the
pad
first
fit
in a
checks and
series
things like
of
that.
tests in preparation for New Glenn's first launch.
I mean, think about it, chat. I mean, Blue Origin, say what you will about them, they definitely operate a little on the slow side. They definitely are a little bit more secret than competitors like SpaceX and ULA. But man, when they do something, like they're very smart about what they do. They're using New Shepard to test their landing configurations. I mean, of course, it's a big step up from landing this to landing this, right? But they're testing, they're being able to test. They learned how to handle Hydrolox motors for a Hydrolox system. They have their BE4 engines that are actually being sold to another company to be used to gain test and flight heritage on. Pretty good. it's, you know, it's a pretty good process. But anyways, chat, that was the NS-25 flight from earlier this morning. They operate a bit legacy, a bit too legacy, if you ask me. But yeah, that's a good way to put it. I do wish they were a little bit more open, a little bit more forthcoming. But it's good. It's good to see them working out. Blue's very much don't show something until it's ready to be showed. Yeah, even then it's like, don't show them everything. I mean, obviously you don't show them everything, but like, even when something is ready, there's like just, they don't even do like an actual release, you know? Like, they're released like this, right? All the pictures from everything like were released after the fact, and we were actually getting like NSF live showing the pad erecting and things like that. Like, it's like, come on, if you're doing something, show it. If they buy ULA and get Tori, now that would be pretty incredible. But I don't know. Has there been any updates on the whole ULA possible selling and stuff like that? I remember that was like a rumor, but like a rumor from a couple months ago or whatever. But I haven't really heard anything new about anything like that. And how did that even start? I don't remember. But anyways, chat, what do you say we kick things off in KSP? Let's see if we can't automate some launches, yeah? Yeah, you haven't heard anything? Yeah. And we are no longer in replay. There we go. No, stop it. Well, I mean, I don't think it was an actual rumor, but I just don't remember how that started being discussed as like a possibility. Like, I just don't remember. Like, was it an actual rumor? I actually thought we got confirmation that that was a thing, but I don't remember how or why that started or whatever. I don't remember. All right, let's go ahead and fly our DCX and figure out where we left off. Was it because like Boeing or somebody didn't want to pay their portion of the ownership or something like that? Or maybe it was Lockheed. It was like, okay, we're not sure if Lockheed's gonna rebid. Ellie's shoe with buckets. Yeah, unless they buy it out. All right, so this looks to be the right save. All right, so from where we left off yesterday, chat, we started implementing some additional control logic for this vehicle, and this is essentially my version of New Shepard, but based off of the McDonnell Douglas DCX vehicle. If you guys don't know about the DCX flight, what an awesome piece of spaceflight machinery. So DCX was being built by McDonnell Douglas back in the 1990s as a suborbital test article for what would be a much larger single stage to orbit vehicle. Yeah, so this is it. Quite literally, what it was used for was doing what SpaceX used their Grasshopper for. All of the GNC required to figure out how to fly this thing, to figure out how to do propulsive landings. It used 4 RL-10 engines, which is pretty awesome. So it was Hydrolox. And yeah, they basically had it go up. They would then have it translate to a new pad and then propulsively land. That's essentially what this is, the vehicle that we've modeled in KSP, and we've built ours to be basically like New Shepard, carrying people, in this case Kerbals, up above the into the very, very high suborbital flight, ideally above the Kármán line, or the Kármán line. There you go. It's basically entering its altitude check, and then it should pitch over. There it goes, and is now flying towards the pad that is designated for. Only use for them, indeed. And then there you go. It's entering its landing configuration. Ah, so good. So good. Yep. So right now it's falling back. It's in its landing configuration, just like Falcon 9. After translating to its new pad, and now it should be near the ground, ramping up its propulsion. You can kind of see them sputtering a little bit as they're throttling and whatnot. And then it will come in for a nice, easy landing. Now I hope this one isn't. Is DCX Flight 8 the one where it tipped over? It's unfortunate, chat. This program was very promising, and then they lost their test article, not because of any sort of GNC failure, but because a landing leg failed to deploy, and so when it landed, it then tipped over and exploded. But no, this does not look to be the one that it failed. But yeah, there you go. You can see the yeah, nice. Pretty awesome vehicle. So that's what we've developed here in KSP. Japan also experiments something similar. I'm not sure. So what we had before yesterday is this thing essentially went mostly straight up, entered a belly flop configuration to come back through its descent. Then once it always aligned itself with the pad, but pointing at a specific pitch angle constant of like -10 degrees, which means that it can get forward flight. And so we were experiencing problems with it overshooting the pad before it can actually get into its landing configuration during its horizontal flight regime. So what we did yesterday was we implemented another control system in mode 2. This is for the descent and landing burn calculations. And we created a controller that is designed to manage both its distance to the pad and its horizontal velocity. So we basically use a cascading controller here. The velocity is acting as a damper to the pitch controller. So if we're very, very far away from the pad and have a very, very small horizontal velocity, it's going to command a very, very large pitch down so we can get up some velocity. And then as we get closer, or as our velocity gets really, really high, we're going to start pitching up to start slowing down. So that is what we implemented yesterday. It works quite well. And what I would really like to implement today is two things. Probably a similar, probably almost an exact copy of that control system we implemented yesterday, but for our pre-engine start guidance here. So basically right now what we have is get it as close to the pad as possible, and then if we go below 3,000 meters, point straight up for landing configuration, right? Except that's not really useful because, like Falcon 9, it's controlling its pointing vector all the way through landing. So we don't want to just hold a 90-degree pitch angle, because depending on where we enter that landing configuration, we still might be a little ways from the pad. So we need almost an exact copy of this controller, but for that period starting at 3,000 meters. And then finally, probably in mode 3, when we enter our constant rate of descent, probably want to implement a controller to null out our horizontal velocity. Because right now, if we come in at an angle and we go vertical, we can still have a horizontal velocity component, meaning that we're translating this way as we're landing. We're doing a drift in the air as we're coming in for a landing, and that's bad. Because if we land with a horizontal velocity, the vehicle's going to tip over. So it'd also probably be good to implement a horizontal velocity controller in mode 3 to try and have us angle a little bit to try and null that out. So we got some things to probably work on today. All right. so this is what we have before our work today. So we're going to go up to roughly 60 kilometers altitude, and let's just see what happens. So this is all autonomous, all hands off. Three, two, one, engaged. Interesting. I wonder if I need to restart KSP. My Go LXLR is not affecting its volume, which is unfortunate. Oh well. We are looking good though. All right, we should be now cruising up to 60 kilometers altitude. Excellent. Let's go ahead and time warp until we're there. And there we go. So I think what we want to do potentially is here. I actually don't care about it entering the velocity hold, so let's just go ahead and do that. Okay. Very good. So this is it calculating its distance to the pad, the horizontal velocity towards the pad. In this case, negative would be away from the pad. The commanded pitch based on the distance to the pad, and then the commanded pitch based on the horizontal velocity. So you can see that we're going increasingly negative because we're starting to move away from the pad. And that should balance out here pretty well. What the Japanese vehicles was, it's called the RVT for reusable vehicle testing. Ah. Yeah. Ah, yeah. Yeah. It actually reminds me more of like Zodiac or Zombie from Mass and Space Systems. Easy does it. We're looking okay. Still looking fine. You see we're commanding more and more pitch because we're still getting further and further away from the pad. We just need that atmosphere to start getting thicker so we can start moving towards it again. And now we're actually starting to increase our horizontal velocity towards the pad, and so now it's starting to bring our desired pitch in a little bit. Go ahead and implement our additional RCS control here. Yep, now we're starting to pitch up because we're starting to get a very, very high horizontal velocity. Yo, what's up, Chief Engineer? How are you doing? And now it's really trying to pitch up. The aerodynamics, though, are a little wonky when you're coming straight in via belly flop. There we go. Commanding pitch down towards the pad. Looking good. Still got some altitude to play with. We're still moving towards the pad. Looking all right. Yep, we're trying to be right there, chat. It's guiding itself in nicely. Once we hit 3,000 meters, it'll pitch over. There it goes, entering our horizontal landing configuration, or I should say vertical landing configuration. And you can see that we're still kind of far away from the pad, right? So ideally we implement another controller during this time to help us move closer to the pad, and then it automates the landing burn timing, and there we go. But you see, we actually still have a little bit of a horizontal velocity, so it'd be great if it could do something like that. That was me doing that, where it could actually pitch in the opposite direction to try and nullify out our velocity. But overall, not bad, right? We went up 60 kilometers and we're about 500 meters away from the pad, from the desired landing location. For linear control, I feel like that's pretty darn good. And we can, of course, improve it along the way as well. With the wind mod, ooh, adding more non-linearities when we're using linear control, that sounds like a bad idea. That sounds like a bad idea. When you start somewhere, you'll need to have a barge out there for landing. That is true. That is true. Not a lot of fuel remaining. I think you mean it's the perfect flight regime for this vehicle. We've calculated it perfectly, I think is what you actually mean to say there, Thomas. Anyways, let's go ahead and reload. That's where we are currently with our flight avionics for this vehicle. Let's see what we can do here moving forward. So, for the most part, I think it's pretty good for what we have. But we could probably use, almost like I said, a direct copy and paste of this code, but here. So that way we're continuing to change our pitch even after we enter landing configuration. And I wonder if it would also behoove us to, instead of wait until we're 3 kilometers in altitude, to just enter our vertical descent, our vertical configuration, when our distance to the pad is very small. That could also be an option. The only reason why I see that as being a possible negative is if we, for whatever reason, you know, are at 60 kilometers in altitude, we hit our apogee, but we're still very close to the pad in terms of our latitude and longitude, then it's just going to go directly vertical, and then we're going to go screaming through the atmosphere on our descent. The whole point of the belly flap is to increase our drag area, so that way we ideally don't pick up a lot of velocity, a lot of vertical velocity in our descent. Think of like a skydiver, right? You can skydive and go, you know, straight up like this, and you'd go screaming through the atmosphere faster than if you laid out and went, you know, belly first. Your terminal velocity is different because your drag area is different, right? So that's a potential bad thing I see, for just changing this line to be whatever, if based on our vertical, our distance to the pad. But that is a consideration. Aren't you going to use more fuel now to correct that horizontal travel? I mean, it's only RCS. We won't be using our main engines until the main engines are only turned on for the hover slam. So yes, we will, I guess, use some, but ideally not too much more. It's already using a lot trying to get into a vertical landing position when it's traveling horizontal, right? So we'll see. We'll see. The other thing is, chat, I wonder, I do wonder, would it be actually good to separate this out for before burn and after burn? Because if the engines are not ignited, and you say the pad is here, right? And we are here. If we always say to just aim ourselves at the pad, then when the engines start burning, we're actually going to be pushing ourselves away from the pad, because our thrust, right, is taking us in the opposite direction that we want to go. So it almost needs to be 3 control logics here, where if we're not burning our engines and we're in our vertical landing configuration, then we want to point towards the pad, so we use aerodynamics to guide us towards the pad. But then as soon as our engines start, we actually want to flip ourselves to be, you know, aiming the opposite direction, away from, or it would actually be away from the pad, if you will, so that way our engines push us towards the pad more. Does that make sense? I think that's actually something that we might want to do, but maybe we'll start one step at a time. And first, let's just try to implement the control logic that we have here, but here, so we always try to aim ourselves towards the pad. Yeah. That might be good. So, let's actually just do that. Let's just try and straight copy what we have here. And put that here. So now we get our current position, we get our heading towards the pad, we calculate our distance to the pad still, we have that. We might need to update our PIDs for these, but for the moment, we might be okay. And then if we're angling or if our horizontal velocity is towards the pad, yeah, let's just actually see what happens if we basically just copy and paste this over. We might actually want to also change our, because what is it set to right now? -20. So we cannot hold on there, chat. We cannot just copy and paste it, obviously, because we actually need this to be 90 degrees off of what our current is, right? Our current implementation is angled around, or is centered around 0, horizontal flight. So we actually need to center it around 90, so that way it does this instead of trying to, because we want it to be engines first through the atmosphere. So we actually might need to change that. Just saying. Also, we might actually want our velocity pitch to have less of an effect, because we're going to be in a vertical landing configuration, and we probably want our distance to the pad to be the main thing that we are commanding. Horizontal velocity can still be the damping term to try and limit how much we're pitching, but at the same time, if we're still really far away from the pad, we probably want to be angling ourselves more towards the pad since we're at such a low altitude. I do wonder, let's actually just do 0 times this for a second. I just want to see how it performs, only having basically our pitch proportional to our distance to the pad and nothing else. That seems good. We still get our sign angling correct. And then we need to figure out our pitch. And so I'm pretty sure we want our pitch to be 90 degrees plus that. Yeah, let's try that. I'm curious to see if that's going to work like that. Let's fly it. Actually, you know what? Before we do that, let me actually change it. Since we're going to be testing, let's only take us up to, say, 6,000 meters. That might not be enough for a test. We'll see, but I don't want us to have a 3-minute flight because we're going up to 60 kilometers every time. There we go. There we go, entering coast. Very nice. And it should now go into horizontal landing config, or horizontal descent configuration. It is calculating what we need. Excellent. Should start pitching up here pretty quickly because we're gaining a lot of velocity. Yep, there we go. Nice. We are starting to slow down. There's our landing config. We're going to start the engines immediately. Oh, okay, okay. So that's actually the opposite way that I want to go if our engines are off. But look at that, chat. See? We're burning towards the pad. Yeah, we're burning towards the pad. Wow, okay. And then we're definitely going to need to implement that velocity controller now for that. Oh! We're definitely going to now need the horizontal velocity controller on our descent. Okay, well, but see, that's the perfect example of what I was talking about. So under propulsion, we're going to want to burn towards the pad, right? And if our burn flag is false, we want to angle away from the pad. So that is the key. So let's go ahead and see what we can do with that, chat. So here. Yeah, don't mind the twitching rocket. It's fine. It's totally okay, chat. It's totally fine. Nothing to worry about. Because I think all of this is okay, except we want, if burn flag is false, no, sorry, is true, do this, else do this, and aim angle the opposite direction, the opposite amount. No, wait, is it pitch? Because pitch is bounded. Wait, does that actually work doing 90 minus and 90 plus? Because pitch is bounded between negative 180 and positive. No, I'm sorry, negative 90 and positive 90. Well, I guess we could try this and see, but it actually might be our heading that we have to change. That if our burn flag is true, our heading is equal to our heading plus 180 or minus 180, mod 180. No, not mod 180. Yeah, plus or minus depending on what side, what our heading is currently. We basically need to, if we're coming in this way, and our engines are on, we actually want to be flipped 180 degrees, right? So that's what this is trying to get at. Well, it actually wouldn't be 180. Our heading would be 180 in that case. But our pitch would only be, it would be the same amount, but we would be angled in the opposite direction. So our heading would be 180 degrees offset. We'll see. Let's see if this works. Yeah, we'll see if this works. It's just trying to be Starship. Yeah, exactly. It's just trying to be Starship. Because what are we printing out here? We are printing out our pitch input. So it's going to be... So that's how we get negative. Is it ever positive, though? It is never positive. Okay. So I do wonder if that's just going to have us angling at 90 degrees because it's bounded. Oh, I guess only one way to find out, right? Only one way to really find out. I think the bounding is going to be an issue. I think we actually have to change our heading. So if burn flag is true, then our heading is whatever we're calculating it as. If it's not, then it's actually going to have to be 180 degrees offset. But we're going to have to do a check on that because the heading is bounded between 0 and 360. Math, chat, math. And reference frames and all that jazz. There we go. All right, commanding. Very nice. Starting pitch up because we're moving towards the pad. Excellent. Should be pitching up even more. It most certainly is. Now we're in landing config. So the engines are on, so we actually need to go higher, I think. So we burn more fuel. Or actually, you know what? We might be able to just do it again as soon as we land. Because I want us to have a little bit more time before we have to start burning the engines. So we need to be lighter. But hey, how about that, chat? Oh my god, we need that velocity controller. Okay. It's not bad, though. That's true. Could do that. Actually, do I have that already? I do have that installed, don't I? Yeah, we do. Aha! That's actually a great, how do I show that, though? Oh, show in flight. Is that all I needed to do? Aha! Beautiful. So yeah, that'll show us our velocity, or our land. It'll show us our landing zone, but not our velocity, right? Hmm. Okay. We'll run with that. Yeah, that'll show the landing. Yeah, cool. Cool. So I don't want to refuel or anything. Let's just... Well, actually, I might want to refuel a little bit here. That seems reasonable right there. There we go. That's how much I need right there. Perfect. All right, let's try it again. 2 streams in 2 days. I know, I do spoil y'all. Kappa. Okay. Let's try it again, shall we? We're gonna take off right now. So remember, this is now gonna be our landing spot. Or at least our desired landing spot. Sweet. Oh. Oh. Neat. It's showing our trajectory as of right now. Hence why it's called the trajectories mod, chat, right? Oh, that's awesome. Very nice. Okay, getting into our landing config. So we're starting to move backwards, as we can see. Yep, we're moving backwards at negative 33 meters per second, so we should be angling pretty far down to start moving towards the pad, and there it goes. Awesome. Brilliant. Uh-oh. Okay. Into our landing config. So yeah, you see it's actually pointing the opposite way that I want right now. Now with the engines on, we can point that way because now it is actually moving it towards the pad. But I think it is a matter of heading. We actually want to head in the opposite direction. And so this is why we also need a velocity controller, chat. Velocity control, velocity control. Wait. Whew. We're fine. We're fine, chat. Don't worry about it. Okay, so it's actually not pitch. The burn flag is true, that's fine. So I need it to be heading is going to equal or plus equals heading, no, plus equals 180. And then if heading is greater than 360. Is there a better way to do this, chat? Heading minus equals 360. Is there a better way to do that? I feel like there definitely is. So basically whatever we are, if we're not burning the vehicle's engines, then we want to actually point away from the pad, because that's going to actually, using aerodynamics and our body lift, actually direct us towards the pad during flight. And then as soon as our burn flag is true, which means our engines have started burning for landing, we want to actually flip ourselves and land and start orienting ourselves 180 degrees. And then it should be this plus. Well, actually, I guess I don't need both of these, right? I can actually move this just out. What's up, Make? Yeah, Screech, exactly. Okay, well, I think that can work. I think? Question mark, chat. Let's take some propellant out so we don't so we're a little bit lighter than we otherwise would be. What you want, huh? Yes. Oh, chat. She's so needy. Are you needy? Yes, you're so needy. What do you want? What? You're fed, I walked you, I played with you. What do you want? You didn't like me being loud? You're okay. Alright, watch your toes. Watch it. All right. So let's see just what we can do here, chat. We should be good to go on that front. Let's go ahead and see how we are in flight. There we are. Ah, this mod is amazing. I like being able to see it. Visualize, chat. Visualize. Should be cruising up to 6,000 meters. Should be almost there. There we go. Sweet. That's our current landing spot. There we go, landing configuration. All right, well, let's see what happens, yeah? I like that this part is correct. So there you go, we're aiming towards the pad, we're starting to pitch up, trying to nullify our, oh, look at that. Look at that though. We're aiming for the pad check. All right, but then we enter vertical. And it looks like we're doing good there, actually. And now we're burning the engines. Wait, were we? We're burning the engines toward the pad. That's good. I couldn't tell if we were actually aiming ourselves, though, towards the pad or not. That was me at the end doing the doing the velocity null out. Okay. All right. Could not tell if we were actually angling ourselves correctly here, though. Are we still in this control loop during that time? Do we have a printout for that yet? Somewhere? Standby. When do we enter mode 3? So if our surface altitude is less than 50, or our vertical velocity is greater than -5. Wait, shouldn't this be an and? Oh, it's greater than. Greater than -5, meaning positive. Okay, not more negative. So yeah, that's fine. Because if we start going up, then we want to enter our vertical descent. And then if we're less than 50. Actually increase that a little bit here. Go to 80. Gives us a little bit more room. Burn flag is true at that point. Oh. Wait, no, that's right. Yeah. Okay. Mode 2. If burn flag is true, just use the heading, else heading plus equals 180 degrees. Then if heading is greater than 360, heading, we subtract. Wait, should we be subtracting 180 or 360? No, 360, yeah. Because if this is 361, then our heading should be 1. Yeah, okay. That's fine. Could not tell if our angle was actually correct. So I wonder if I should negate this. Let's just have it be greater than 300. Or let's just have it be greater than 0. So it always enters this one, so we can test it during the whole descent. because I really want to test this code and be able to see what it's doing. So we'll have it do that. All right, so let's reload and run it back. See what we can do. All right, once again, into the breach, chat. There we go. Perfect. So we are angling ourselves away, which is not correct. So then does that mean that we actually want, and okay, burn true? Are we actually angling ourselves towards or away from the pad? I feel like it's not changing now. Why? Is it our roll that needs to be the opposite? I thought heading would have inverted us. Coming in hot again, chat. Oh god. Oh goodness. Yo, Wymill, or Wymill. Thank you so very much. I hope I'm pronouncing your name right. I don't feel like I am, but let me know. Thank you so much for the Twitch Prime subscription. Much love to you, my friend. Is it Wymill? How are you? Hope you're doing well. I want to figure this out, chat, because why? Why? Yeah, don't worry about that, Make. It's fine, okay? Just look away, all right? Avert your eyes. So heading. We're calculating our heading the same way. This computes our line of sight angle to the pad. And then we should be adding 180, which should have us head the opposite direction. But I wonder if this actually needs to be roll? We have vertical speed regulator. It's the horizontal speed that we need to regulate at this point. Yeah, once we get close to the ground within 80 meters, we enter a 5 meter per second descent rate, constant. So our vertical is fine, but it's the horizontal that we're definitely going to need to implement sooner rather than later. Let's see if burn flag is true. Let's do it. Let's try it out, shall we? Target roll equals 0. Else vessel.auto pilot.target roll equals 180. Huh? I'm trying to remember, because I thought heading, which is almost our yaw, but it's actually our compass heading, that... Oh, do I need to set target roll set to 0 at all times? I don't know, where do we have target roll? No, yeah, we have target roll set to 0. If we have target roll set to 0, then... Mm-hmm. Sorry, I'm just looking through it, trying to see if there's So I do set roll to be 0, and I don't change roll anywhere else, so it should always be 0. So I feel like if our heading actually does change by 180 degrees, essentially changing our direction completely by 180 degrees, then our roll should also remain at 0, so we should actually roll as well. Well, let's see what that does first, see if that actually changes things. Because if burn, and it is called burn flag, right? Like, I'm not, okay. Yeah, if burn flag is true, then we keep our roll. Otherwise, change the roll by 180 degrees. I don't think that'll actually change anything. I wonder if I need to change the roll and the heading, or just the heading. We'll see. I think I should be heading, so I don't know why we weren't seeing a change in the direction that we were pointing there. We'll figure it out. Yo, what's up, RJ? How are you doing? Would you send your pad to me? What does that mean, RJ? What's good, man? Which pad? What? Wait, what? Huh? Huh? The Atlas one. Oh, yeah. Yeah, I can do that. You want the crane too? You talking about when we were in career mode building our pad and stuff? So it's not KOS. You want KRPC is the mod. Sure. Yeah, I'll see if I can't put that up on KerbалX. Can you send me a Discord private, just so I can remember? All right. Oh, there we go, chat. Now it's working. So it was the roll. So the heading wasn't actually changing it. Okay, interesting. Look at that, chat. We're guiding ourselves in. Now the question will be, is it going to do a 180-degree flip? Because see now... No. No, it is not. Wait, so was it working previously before? I'm so confused by this result here, chat. I'm so confused by this result here. So roll, it was not the roll then? Yeah, see, this is why we definitely need a horizontal velocity controller now, chat, because this is not it. This is not it. Stop. Nope, we didn't make it. Yeah, definitely need a horizontal velocity controller on landing for that very reason right there. So I'm confused, chat. Hold up. If we take this out, take that out, what is the effect? So was it actually working and I just didn't notice or didn't see or something? I definitely feel like I don't know. Don't know yet, chat. We'll see. Okay. So that is angling the correct way. So without changing anything, we are angled the correct way, yeah. See, we are angling ourselves towards the pad. We're flying it in like a Falcon 9 rocket booster. burn is going, and now we're still aiming the same way, which is bad because now we're pushing ourselves away from the pad, right? This is me. I'm doing the manual, trying to make it vertical, chat. Oh god. Okay. Uh-oh. Uh-oh. All right, there we go. Whew. All right, so that wasn't it. So what is our heading? I should probably be, you know what? I should probably be printing out my heading as well as another thing, so I can actually see what it's doing in that case. This pitch should always be, desired pitch input should always be negative. The only thing that should change sign is our heading. Well, not, it shouldn't even change sign because it's bounded between 0 and 360. I want heading here. And I guess in that case, I should also have a burn flag. Yeah. This is Python 3.88 that I'm using right now. Yeah, it's VS Code. Just using VS Code. All right, let's actually go back to what we had then. Because apparently, chat, apparently, this has nothing to do with it. So if burn flag is true, we want to change our heading, right? So vessel, yeah, we want to change our heading. So heading, which we're defining here, should be plus equal 180 because we want to actually go the exact opposite way, face the exact opposite way. And then if heading is now greater than 360, we want heading minus equals 360, right? Again, if you guys know a better way to do that little bit of code right there, would greatly appreciate it, because I feel like that just looks disgusting to me. But and then that, you know, else nothing, honestly. Like, just if that, then that would be the best way to do it. no, I'm the ninja. You can use Python. Use the KRPC mod, KRPC. Maybe if burn flag equals true, target pitch equals. So here's the thing though. So, well, actually, no, because we can, no, okay. So here's the thing about the whole target pitch thing, right? Is your pitch is bounded between negative 90 degrees and positive 90 degrees. So right now, our commanded is always negative, right? Meaning that it's going to be 7 degrees offset from 90. If we do positive and we try to do 97 degrees pitch, then that doesn't exist. The maximum it could be is 90. So we need to change our heading, I'm pretty sure. So that way it's effectively doing what you're suggesting, but it's switching, it's literally changing the direction of the vehicle, the compass heading, which should effectively be the same as going the opposite way, basically trying to pitch up to 107 degrees. So yeah. Sorry, up to 97 degrees, not 107. But yeah. Yeah, no worries. Yeah, we're all figuring it out together, you know? Game limitations and things, like, it'd be great if we could just implement everything, but we're working with some of the assets in KRPC, so it simplifies other things. You could do heading equals heading plus 180 mod 360. That is true. Mod, thank you very much. And how you doing, my friend? Hope you're doing well. Yeah, so it can be done to like one line. I thought it could. Are these using something to do with Euler? Yeah, it is using Euler angles. You can use quaternions. You certainly can. I think KRPC has it, but KRPC also on the back end knows how to just work with Euler angles, so that's what we're doing, so we don't have to do any rotations and things. All right. I guess it would be projections, right? Not rotations. You project yours, right? Because a rotation is like you have your X, Y, and Z and you're rotating it into a different frame. But a projection is what you actually take one set of values and actually, or is it a transform? Yeah, it's a transform. Yeah, you're transforming it into something else, right? Projection. What's the difference, chat, between transformation and projection? There is a difference. My terminology is lacking. Misremembering. It's been a minute since I've had my GNC class. All right, let's see what we can do, chat. All right, we're up and away. Our estimator should now be estimating our apoapsis target. We're aiming for around 6 kilometers. There we go. Bring it back. Okay, we are now correctly aiming towards the pad. Oh, our burn flag is true. Is that why? Why is our burn flag true? That's why it never changes. Right? Because when the engines start, like right now, the burn flag is always true. Because see, the engines are on and we're still basically pointing away from the pad, and we actually want to point towards the flag. The burn is always true. That, I feel like, is an error. Because burn should only happen here. And tip over and die. So if altitude is less than... Oh, that's why. So we can't actually... we can't use the burn flag because that is for me to not do our complex time to burn calculation. That's why. Okay. So I was thinking burn flag. I was thinking I had burn flag being set to true when the engines actually ignite, but that is not the case. So we actually need to get the thrust. So if vessel.thrust is greater than 0, which means the engines are on. Yep. That's what we need. It could be another let's do what do I actually want to do here, chat? There's a couple ways to do it. I think I just want to do another flag. It's pretty easy. We could do burn start flag. Oh my god, if I could type, that'd be great. Just going to start off false. If you're looking for the socials, we're still using the outdated Twitter. It's now X. We're also live streaming on YouTube, all that jazz. Why don't you add some filtering surfaces? We do, our lifting surfaces. So we do have some lifting surfaces. I can actually show you. If I can see in game, there we go. Oh, never mind. You cannot see it because the vehicle no longer exists because we crashed, but if we roll it back. So the great thing about KSP is it actually models body lift to some degree, meaning that the tanks in the game, the fuselages, the panels in the game, pretty much everything, if it's not an actual wing, has body lift. It actually does create some body, some lift. The fairings in the game create lift, so even though we don't have any control surfaces other than these little small flaps for directional control, we actually still are creating a good amount of actual lift on the vehicle, which is how we're able to glide it in towards the pad. And it's actually doing pretty all right there. But then again, I don't deal with Python. Yeah, maybe that's just me and my Rust background. And like working in embedded systems, we use flags often for, well, at least I do. At least I, for embedded systems, use like a flag for something to occur. But you're right, it probably is more Python idiomatic to be like is burning or is landing or whatever have you. Okay, so burn start flag. We want that to probably happen. So we're falling. Probably in here. So if, oh, I need the docks. Thrust. Is there like a vessel thrust, engine thrust, vessel dot thrust? I want the Python though, not C#. So the total thrust currently being produced by the engines, this is computed by summing engine dot thrust. Okay, so this is what we want. And it's under vessel. So just vessel dot thrust then. Okay, cool. So if vessel dot thrust is greater than 0, then we want burn start flag to equal true, right? And then here we can do burn start flag and do something like that. I wonder if that needs to be false now, because with KSP the tanks feel like they have no drag compared to the fairings. That is true. Yeah, there's definitely some wonky things in the aerodynamics with KSP, but it's generally speaking, it works how you want. But yeah, like if you just have like a stick rocket, right, aiming vertical, the drag cube, they use drag cubes, basically the cross-sectional area of your vehicle as a cube to compute the drag. Yeah, it's going to go screaming through the atmosphere because it's creating very little drag, unless you belly flop, which is why the vehicle that we have here actually goes into a belly flop mode. Now I've disabled that belly flop mode for now because we're trying to test the vertical landing control. But yeah, to increase our drag so we don't go screaming through the atmosphere during landing, this thing actually belly flops like Starship. So once we get this code figured out, we'll do the whole thing, belly flop and all. Okay, so let's see here. Burn start flag is true. We're going up to 6,000 meters altitude, and see if this now works. Okay. My day-to-day lately is crystal reports, which the syntax is very similar to Delphi and Pascal. Nice. You know, I don't think I've ever seen... I don't think I've ever run across Delphi. Oh, so that's what that looks like. Huh. Seems somewhat intuitive. Nice. Yeah, Delphi is Pascal, yeah. I've never seen Pascal. We should just put it that way, huh? All right. So we are now aiming towards the pad correctly. That's good. Oh, you know what? I should have changed my my printout here because we're printing out the wrong thing. I want to be printing out for future. I want to be printing out burn start flag and not burn flag. So heading did not change there. Is it not the heading that needs to change? That's the thing, though. All right, well, let's go ahead and roll it back, chat, real quick. Now that we're printing out the correct thing, I actually want to see if the flag is changing appropriately, because it should start off at false when we're going into descent, and then as soon as the engines turn on, it should become true, and then this should take effect. And are we using the heading anywhere, actually? Wait, are we? One second. Oh my God, are you kidding me? Such a silly head, chat. Unbelievable. No wonder that's not updating. It's not updating because I am not changing our heading. Unfreaking believable. Wow. Oversight by my end. That's what you get for copying and pasting. Yeah, target heading equals heading. We now have target heading equals heading after we're changing the heading. Unbelievable, chat. Where were y'all? Y'all are supposed to be my paired programming supervisors. We're doing paired programming here, chat. Come on, y'all were supposed to check that as I'm writing it. Where were y'all, huh? I guess it just goes to show you paired programming doesn't work. Oh my goodness. Paired programming proven doesn't work here on stream. Oh goodness. All right, let's try it again. We're now printing out the right thing. We are now changing our heading appropriately, ideally, hopefully, and we're now actually updating our heading. Oy. So of course we didn't notice the heading. Yeah. I'm only qualified as a rubber ducky. Okay, well that's understandable. Okay, well then you're excused, Wasp. But everyone else in chat, all you programmers out there and engineers, where were you? We're just watching. That's what paired programming is all about. Paired programming is one person is programming and then another person is sitting next to you looking at what you're doing as a check. It's the whole concept. All right, there we go. Currently aiming. Uh-oh. So do I have it flipped? I have it flipped, don't I? I do have it flipped. Okay, cool. Well, that's good to know. But it is working, I think. So now we just need to see once the engines start burning. Once the engines start burning, are we going to flip the other way? And if so, then awesome. It works by not working, chat. Okay, so this should be when false, do that. Otherwise, do that. Okay, bringing it back, chat. Bringing it back. Yeah. I just accidentally F5'd and I'm sad because F5 is going to keep us from being able to bring it back to the pad simply. All right. Also, can I not have to fight you during landing here? Thank you. Perfect. Gosh dang it, chat. You know what we're gonna have to do? Because I made an oopsie and I F5'd over our F9 save, we're gonna have to roll it back, chat. We're gonna have to go get our, we're gonna get our pickup truck here. We're gonna have to go over and get it, bring it back to the pad, F5 again. We're watching The Watcher. Crew member name here, chat, by the way. They're the real heroes. Error, success, exactly. Exactly. Not to remember, yeah, fair enough, fair enough. Not to remember uni, I understand. But no excuse, okay? There's like at least 40 of you in here. I should have 40 paired programmers helping me out. But no. It's like, what is the meme, chat? Construction, it's like construction workers. You ever drive by construction, there's always like one guy digging something and then like the other 20 people are just watching. It's not how it's supposed to be. Oh, what's up, Boom Boom? How are you? How are you doing, my friend? All right, let's not hit the vehicle. Okay, thank you. All right, let's make sure we turn the thrusters off. That'd probably be bad. Let's just turn SAS off. RC, yeah, let's just do all that. Let's safe the vehicle. I should have done that first. Okay. There we go. Perfect. There we go, chat. Easy peasy. Is the vehicle really too heavy? Hold up. I think we should be okay. Well, oh, that's right, chat. I forgot. We didn't burn out all of the fuel. This thing is designed to be yeah, still has a lot of fuel in it, indeed. Okay, well, we are docked. How much fuel does it have? Okay. Guess what? Let's just do this. Mods for the win, chat. Goodness. No reverse beeping? Nah, sorry, I forgot. Before attempting to assist, fair enough. You know, fair enough. Okay, you know, that's reasonable. Oh, there it goes. For whatever reason, sometimes also the landing gear in the game actually get like stuck to the ground, which is kind of weird. So I wonder if that was actually our issue. Because you saw it there too, and it's empty, and it should be totally fine. There we go. There we go. Put it under tension. Bring it up. And we're off. And now we can drive it back to the pad. I don't know what happened to our scatter, but yeah, it's gone. Our pretty flowers and plants that we had on the surface of Kerbin no longer exist. Go figure. Are YouTube chatters first or second class citizens? They are certainly on par with Twitch. 100%, you know, equality there. on the same tier. There you go. So both Twitch and YouTube channels are first-class citizens. How about that? Streaming service segregation. No way. Stop it. You're horrible. Deals alone to be a citizen here. Yeah, it's because I just started streaming on YouTube, and I definitely do not have a following on YouTube yet. That is 100% sure. But we'll get there. I have quite a number of projects in mind that will probably be only YouTube based. I don't mean like live streaming, but like YouTube videos, you know? More like VIP. That's right. More like VIP. VIP service. And bringing it back, slowing us down. And now we do the same thing, but in reverse order. Not actually gonna put the truck in reverse, but you know. All right, target extension, bring that up, and boop, and lock it out, and then target to 90. And then at the same time, we can drop this a few degrees. There we go. Perfect. And down. And there we go. Sorry, traverse rate is fine. Unlock it. Boom, boom. And oops, undock. There we go. Okay. Let's go put him somewhere safe. And by somewhere safe, I mean, you know, only like 10 feet from the pad, but it's okay. We're good. Yeah, and so the pad safety is going to be behind this little wall right here, even though it does nothing to actually protect the Kerbal or the truck, but that's what we got, chat. Or we'll just do that, actually. Oh, please. Oh, come on. You're like right there. Do you want to, do you want to build a snowman? No? All right. If you could just grab that wall with your tires and then have enough traction to move us, that would be brilliant. Now we can use the truck as safety. That is true. All right. Well, you know what? Nope. Negatory. Negative Ghost Rider. The pattern is full. Not happening. No, you know what? You're fine. You're fine right there. You're just gonna chill out. You're good. Having a good time. There we go. Yep, foobar for sure. And there we go. Up to 100% fuel and oxidizer. And ideally, this one will work flawlessly, chat. You know, minus that whole problem with the horizontal landing, I guess. The horizontal, yeah. Minus that whole thing, it should be fine. Do we? No, we do not. That could be a problem. Yeah, that could be a problem. All right, let's do that. just to make sure that we're pointing vertically once we get into the constant rate of descent. That'll be better, because I think right now we're just holding the last commanded pitch, which is not great. Okay, let's do that. Also, let's bring this back to 3000 so we can enter. Well, we wouldn't actually enter a belly flop. We would for a second. And you know what? We might as well, you know what? Let's do minor changes at a time. Let's go with that. Wait. Stop. Aborted countdown. We're gonna F5 here so we can come back to this state, since I don't want to F9 and have to go get the vehicle again. So that seems great. That seems good. Let's do it, chat. Terminated the count with 1 second. No big deal. There it goes. And let's go ahead and time warp a little bit till we hit our coast period. There we go. And there we go. Oh, I never did bring the landing gear up, did I? Oops. Okay, not bad. We are aiming towards the pad, which is perfect. Yo, 415 coming in with the 100 biddies. My goodness gracious, hitting that launch button. I appreciate it. Yeah, it's great to see you again, my friend. Hope you're doing well. Oh, there's the engine burn start. We are now pointing ourselves directly at the pad? Question mark? What is going on here? What in tarnation is happening? This is exactly not what I was thinking would happen. I'm gonna just lay that out there, chat. Just gonna lay that one out there as to say that is not what I was expecting in the slightest. So yeah. Now, why did that happen? Why did that happen? Of course. Don't say a word, chat. Don't you dare say a word. Yep, that'll be the cause. Why? Because we never exited this condition here. Yeah, don't wanna talk about it. So we're not going to. At least I think that's right, because when we we never exited this condition, because we were never, after descent, we were never greater than 3,000 meters after we descended past it, so we never broke out of this loop. That'll be an issue. Yeah. A very good ICBM. It's actually not great as an ICBM, I'm not gonna lie. First off, didn't go intercontinental. Also not ballistic, also nowhere near the target. Actually horrible as an ICBM. Yeah, points directly at the pad. That is true. It did do that as it should have, because this code here in the loop that it never broke out of is designed to aim it directly at the pad. So that's good. Question mark. Let's just roll it back, chat. Yeah, let's just roll it back, and let's get some less intense music here. There we go. Yeah, better. All right, let's coast back up. Let's coast it back up, chat. We're all calm, cool, and collected here. Okay, it's gonna work perfectly this time. Everything about it, chat. Everything about it. Why is the landing gear? There we go. It's totally fine, chat. Everything is wonderful, okay? Y'all having a good time? Hope y'all are. Nice, calm. Everything is great. Everything is grand. Okay, there we go. So now it should be aiming towards the pad. It is aligning itself with the pad now. Perfect. Should be seeing our horizontal velocity change. It should start pitching up here as it gets close to the pad. There it goes. It's pitching up now. It's trying to slow down. Beautiful. We're going to pass 3,000 meters. It's going to go to vertical descent. There it goes. Engines are going, so it should point towards the pad. There we go. It's pointing towards the pad. All right. And entering vertical rate of descent. There we go, chat. That's more like it. That's more like it. Ruins your accuracy a little bit. A little bit. But we're also supposed to be going much higher than that. So let's actually see how it now goes at full throttle. Send it, chat. We're gonna send it. Yeah, what's good, Warlock? How are you? What did we change? We are adding a controller for our vertical descent, so we're also aiming at the pad as we descend beyond 3,000 meters. Because if you recall, we're in horizontal flight, right? We hit 3,000 meters and then we go vertical. But as we go vertical, we then have no other control because it's just basically pointing at 90 degrees. We're now implementing control to keep us moving towards the pad, kind of like Falcon 9 flies in towards the barge or the landing zone. So that's what we're doing now. Next thing that we're going to be implementing is a horizontal velocity controller when we enter our vertical descent. When we enter our like final like terminal landing burn. So we null out our horizontal velocity so we don't land moving sideways and tip over. That would be bad, okay? All right, 60,000 meters target altitude. Let's do it. You found a solution to the RTB code problem. RTB code? Return to base? That one? I think so. It's doing pretty good. Full send. Exactly. Just send it, chat. Send it. Yeah, I mean, basically, I mean, we're able to fly it in towards the pad, yeah. You'll see it here. There we go. We have shutdown. Oh, wow, we overburned because I was fast forwarding way too much, chat. I was fast forwarding way too much. We were going at 4x speed. You know what, let me bring that back because I don't know if we're gonna have enough fuel to land because we really overshot it there. Rocket guy, stop. Time warping. All right, let's try it again, yeah? This time I'll time warp, but not through our apoapsis calculation. Patience, indeed. All of the patience. We should be aiming for 60,000 meters altitude apoapsis. It's going to burn more than that because we actually have an estimator calculating our apoapsis with respect to the dynamics of the vehicle. So we actually have an integrator that's constantly integrating and basically calculating an estimation of what our apoapsis should be, including drag, because this does not include drag. So we'll actually overburn by a slight amount, but it should still be within a couple kilometers of 60. Yep, there we go. Yeah, exactly, Naps. Don't want to be doing that. That is our next implementation. Because right now, because we're burning and pointing towards the pad to try and get there as close as we can, we could enter our terminal descent, which is basically 50 meters off the ground, moving at like, 60 meters per second sideways, which is not great. So we need a controller to help us mitigate that. All right, now we just coast on up to 60 kilometers. There we go. Should then enter It's belly flop maneuver. There it goes. And rotate. All right, we're in our belly flop maneuver. So we're doing this in order to help the vehicle slow down in the upper atmosphere. We also want to try and glide back towards the pad. So when we do this, we're creating some body lift. And you can see here this -9 on that second column is our horizontal velocity. It's actually a horizontal speed. The sign negative indicates that we were moving away from the pad. So as we get into the lower atmosphere here, we should start producing more and more body lift. Nope, don't care about temperature. Don't care about that. Ah, there we go. F12. Haven't had to do that in a while. So we're still moving backwards away from the pad. This is our distance to the pad in meters. Our horizontal distance, not our actual total distance, right? And now that we're starting to get into the lower atmosphere, yep, we're now starting to translate. We're producing body lift. That blue arrow there is body lift, red is drag. We're now starting to move towards the pad at a pretty fast rate, which is good. It's a good thing. This is fine. Aerodynamics are a bit strong. We're really moving towards the pad. It should start pitching up. Trying to get our velocity down, ideally, in a perfect world. Continuing to aim towards the pad. There it goes. Nice. It's flying itself in. I like it. There we go. 3,000 meters is almost here. It should go into vertical. There it is, vertical descent. Continuing to aim itself towards the pad. All right, stand by. Engine start. Terminal descent. All right, that's pretty good. I like it, chat. I like it. Yeah, not too bad. Send it to 80. I don't think we have enough fuel. Well, I guess we could have enough fuel. It'd be pretty close. Yeah, nothing but PID control loops, chat. Like what SpaceX does is they obviously use non-linear control instead of linear control, and they also use convex optimization for that control, or at least probably some implementation of it. So that's really way more difficult, which is why they can actually hit the size of, you know, a soccer field from orbital. But with some simple PID control loops, I'm pretty happy with this. We went up to 60 kilometers. And we are, actually, do we see it from here? We landed 200 meters away from the exact takeoff point. So what kind of error is that, chat? 200 meters divided by 60,000. That's our percentage error. Now take to Joule and have it come back. Okay, let's calm down, Warlock. Yeah, clearly that's the next step, is Joule. Yeah, pretty happy with that. So The next thing to do, chat, is we need a horizontal velocity controller, because what y'all saw at the very end there, when the vehicle was tipping to try and land like perfectly without any horizontal velocity, that was my control input. What I want to do is have that part be automated as well. So hey, 0.3% error, I like it. Thanks, Cletus. Heck yeah, not bad. Now with, you know, with SpaceX, add a couple more zeros there and that's what they can achieve. But yeah, not bad. They also have to deal with like wind. Ugh, disgusting, right? Who wants to deal with like wind and turbulence and yeah, a whole bunch of other non-linear perturbations? In KSP, we don't have none of that, okay? It's nice. It's a nice world here. There's no wind, which I guess if you lived here on Kerbin, that would kind of suck. But, you know, for control applications, beautiful. No wind, okay? No turbulence, nothing like that, okay, chat? Whew. All right, so yeah, let's continue implementing what we want to implement here. So that is going to be our horizontal velocity controller. Not too bad, though. All right, so probably going to actually need to have another PID here with its own gains. I think that's probably where I want to start. Actually, are we using the HVL controller? I think we are, right? We are using the HVL. You know what? We actually might just be able to use the horizontal velocity controller. It's already there. We could just update its gains for that particular logic. SpaceX programmers get paid more. That's true. Okay, that is true. So there you go. Validated here, Kappa. All right, so we're going to use the horizontal velocity controller, I think is what we're going to end up doing here. You know what? Also, I wonder, chat. I know we're going to be changing something else, but I do wonder if we should have our velocity term here as well. Because right now we're nulling out our velocity pitch, but I wonder if that would actually help us get closer to the pad, because probably not, because right now we're only taking our distance to the pad controller, our distance to the pad input. That's probably fine. Yeah. Yeah, okay. Yeah, we're good. But they write in real programming language. That is true as well. Goodness. Yeah, they use C and all that. Ew. Gross stuff. So I think let's see. How do we want to do this, chat? Because there's a few ways that we can do it. We need to get our horizontal velocity component. We need to put it into, I guess, our frame. Or no, I think we should be able to use the same reference frame, which is going to be our ECI frame, or I guess I should say KCI frame. And then from there, once we get our horizontal velocity component, we should actually, let me check. I'm pretty sure I remember that we can implement a target direction, meaning that we can give a tuple to the autopilot and have it align itself with that unit vector. I think it's called target direction. Yeah, it's already been searched for. Okay. Direction vector corresponding to the target pitch and heading. This is in reference frame specified by reference frame. Okay. So I wonder if that could be useful here. So if we get our horizontal velocity component, then it would basically be, that would be X and Y, Z would be 1 for vertical. Or no, I guess it would be 0. Because we don't care about the vertical control, or the vertical, yeah, we're not doing vertical control. doesn't matter what language you write your program in. If it works, it works. Sure, there might be better languages for certain tasks, but if it works for what you need, what's the difference? It still works. That is true. Except with Python. Python doesn't work too well on embedded systems because it's a dynamic programming language, right, versus static. And that's not great for reasons. All right, sounds good, RJ. Sounds good. Okay, so let's first go ahead and get our velocity. So I'm pretty sure to do that. Didn't we already do that? That's heading, distance, current velocity. I actually want, I think, our velocity vector. So let's see. How do we get our velocity vector here? Velocity. Nope, not that. I think it's under flight. So it's gonna be a tuple, yeah. X, Y, and Z components of the velocity in the reference frame designated. So we want vessel.ref frame, yes, dot velocity. Velocity vector is going to be equal to that. And then we should be able to just get our horizontal velocity, right? Horizontal velocity is going to equal velocity. Let's actually do it this way. We need to square it, basically find the magnitude of these. Velocity, velociraptor. We want that to be 0. We're going to square that plus velocity vector again. And we want that to be the first, so that's X and Y, which should be our horizontal components. And then that should be square root, right? Now do this in MATLAB? Ew. Gross. I actually have nothing against MATLAB. I actually kind of like MATLAB. But yeah. And then we should be able to do square roots of this, right? Yes. Good. Good, chat. It's all coming together. Yeah, there you go. Panels, chat. Panels. That's right. Disgusting. Oh, yeah. JavaScript. Ugh. Was it, James Webb? Was it James Webb that used JavaScript? Yeah. The James Webb Telescope runs on JavaScript. Oh, man. Like, why? I don't know, but they sure did. Oh, it's based on a software development kit from 2002. That's why. Because they developed whatever they were using in 2002, and then they didn't want to change it. Yeah. Gross. Yeah, why would you ruin it for me? Oh, goodness. There's hope? Absolutely, there's hope. Oh, goodness. Do you play Minecraft? Oh, can you play Minecraft? Yeah. Yeah, so can you play Minecraft? I don't think so. But, yeah, from what I remember correctly, they use JavaScript because they are using something that's been tested and apparently proven since 2002. Because remember, JWST has been a thing since 1998, right? Yeah. Yeah, gross, right? Disgusting. Revolting, chat. Ugh. Python is for engineers. Real programming language is for CS guys. Real programming language is for CS guys. Wow. Talk about them fighting words. Well, understandable. I kind of share that sentiment as well. I love Python because I'm an engineer. But then I also really love Rust for getting into actual control systems. Yeah, Rust is where it's at, chat. If you wanna do some embedded, if you wanna do anything, just do Rust, okay? Rust Master Race. Can we do remote update and change the entire language on it, please? No. JWST? No. We can't do that. Okay, I'm sorry. Totally sorry. What do you want? What do you want? What do you want, baby? What do you want? You just what do you want? I don't know if y'all can see here. You'll see that? Sorry, I can't see my OBS screen, so I actually have no idea what you're looking at, but I hopefully that's looking at the doggo. Yeah, I see you. You just want pets? You always just want pets. You always just want pets. Yeah, I know. I know. Rocket Gal will be home soon, okay? Rocket Gal will be home soon. And then she'll give you all the pets. That is a dog. Yeah, that is a dog. Good eye. Good eye, RJ. Do I can count on you. Impeccable observation skills there. You're so needy. She might have to go out. I might I'll keep an eye on her. And if she gives the sign, I might have to head out for a second and walk her. Yeah, RJ, exactly. Bring back the doggo treats, redeem. Oh, that's true. I totally forgot that those were off, actually. Alright, I'll do that next stream. Just take the dog out now, Boza? No, she's fine. She's not doing the sign. She has a sign that she gives. But she also sometimes gets needy when she also wants to do it, so I'll watch her. She's okay, she knows what to do. She knows what to do. What's up, Snackless? How are you? Bring the doggo. Yeah, we'll do. We'll work on that. All right, let's roll it back, chat. So, we have our Velociraptor vector. We're trying to get our horizontal velocity vector. Well, actually, our magnitude, right? And we do have that. I know you didn't train her. Wow. Why? Why would you even say such a thing? And then from there, let's do if the horizontal velocity is greater than 0.5. I'm just trying to think, like, when it's that low, it might be moving all over the place, so we don't really want it to do anything if it's going to be that low. Maybe 1 meter per second. We can certainly handle 1 meter per second, right? Because what I don't want is if we're constantly doing the velocity vector cancellation, then once it gets really, really low, we're just going to be like tilt-a-whirling, like a spinning top, as it tries to combat the very, very small horizontal velocity that's switching side to side. So don't want that to happen. So we'll probably stop it. Yeah, probably need something like that. Okay, and so basically what we have now is we now need to calculate our direction, right? And our direction that we actually want to aim is going to be our negative. It's going to be because we're pointing up, but we actually want the opposite of that. Velocity vector is actually going to be pointing this way, but we actually want to be pointing this way. So it's going to be the opposite of our current velocity. Yeah, okay. And we want to just get the unit vector, so we're going to divide that. Jeez. Wow, I just jumped so hard. Good lord. Well, Rocket Gal's home. Goodness me. Ugh. Yeah, that got me. Yeah, sure, RJ. Let me see. Yeah, that got me. Not afraid to admit it. That scared the bejesus out of me. Hey. Yep, Rocket Gal is home. Oh no, you're good, RJ. Probably won't be on for too much longer. Tell me when you're gonna do your stuff. Because it'll probably take a second to find it and whatnot. So also, what exactly, which vehicle exactly do you want, by the way? Is it just the, is it the actual Atlas vehicle? Because we had multiple, right? We had the Atlas inspired vehicle. We had the AVL, which was kind of like a shorter, smaller New Glenn vehicle, which actually had the pad and the crane. But from what I remember, the Hurley is what we called it, right? The Hurley A3, I think, was the Atlas style of vehicle, and that used a horizontal integration pad. But do you want the horizontal or the vertical one? Right? Because the vertical one's just like a ring, and it had the 4 posts. Whatever one works. Okay, well, I'll okay. You probably want the AVL pad then, the New Glenn vehicle. All right, so that one, velocity vector, and then we probably want the same thing, but this one is now going to be the second. There we go. That should be good. The Hurley pad not work. It worked for integration, but not super well because it didn't manage weight very well. And when it was under load from the vehicle, if you did any docking and undocking, it had that massive, you know, when all the parts get like shifted and out of place a little bit, that's what happened. So that's why we went to vertical integration, because the pad could just like not move ever, and the crane would then take the load. All right, so that should be getting our direction now. So from the direction, we need to get our, well, the direction should be for our heading, right? It's going to be very similar to what we did up here. The direction is just going to give us our heading, our compass heading. And then we should have basically our horizontal velocity controller just managing our horizontal velocity. I think that's what we actually want to do. So we can actually call this like the pitch input here is now going to be equal to our horizontal velocity PID, and that horizontal velocity PID should just be tracking our actual calculated horizontal velocity. So HVEL controller, and that's going to be doing our horizontal velocity. Because see, now what we can do is we can actually use the direction for our heading. I think that should be fine. We're gonna have to do ATAN2 and then rebound it. Yeah, it's the robotics. Yeah, the robotics. What did we call that? What did EJ call that? The drift. Yeah, the part drift. Yeah, that stuff happened really bad. The Delta Clipper. That's right. Short line. How are you doing? So we have our direction, so we're going to need to do our heading now, which is going to be equal to oh god, I'm blanking, chat. I think it's ATAN2, right? Yeah, it should be ATAN2. And we're going to want to take the direction components. Direction, I think 0, not direct, direction. And then direction 1. And we need this in degrees. Yeah. So that should be the heading, but again, ATAN2 is bounded between negative 180 and 180. So what we actually want to do is heading, I'm losing it. If heading is less than, right? Less than 0, then heading plus equals 360. Then that should do it. Okay. And so now I think that's all that we really need. So now we need vessel.autopilot.pitch. It's going to be equal to 90 plus our pitch input, because the pitch input should be bounded between positive and negative 10 degrees, I think. We actually might want to change that just to be sure. And then we also have vessel.autopilot. Oh, that's going to be target pitch, by the way. Yeah. That target heading is going to equal heading. I think that's what we need. Yeah, what's up, Josh? How are you doing? So the other thing that we need to keep track of is, like, what do we actually want our controller to be in terms of its gains and its outputs. So I don't think I want to mess with the gains at all, but I think what we can do is once we enter mode 3, actually, when does mode 3 get activated? Here. Okay. So let's go ahead and do hvel controller dot set max output. Let's have that be 10 degrees instead of 20, I think. And then hvel controller dot set min output of negative 10 degrees. And let's see what that does. I think that should give us what we want. But anyways, let's go ahead and reset and try that. All good here? Good to hear. Good to hear. I think that should be fine. Question mark. Unconfirmed, but we'll try it out. And while that actually launches here, which actually we only want to go probably, did I change that back? I think we only want to do this as a quick test, so let's go up to like 15,000 meters in altitude. Just since this is going to be a simpler test here. Mainly for the horizontal velocity controller. Let's have it run. There we go. And in the meantime, I can get this thing for RJ. I think it's this one. We have that. So it should only be going up to 15,000 meters. And then crane. There you go, RJ. I think that's what you need. Check it out. All right. We're going up to 15,000 meters. And it looks like our estimator works pretty darn well, chat. We're within 50 meters error. I'm happy with that. Should enter its altitude hold here very soon. There it goes. Altitude hold and kick over. There we go, chat. It can pretty on the button. That's about as max as it can go. Our typical thing that we fly is around 60 kilometers, just because that makes sure that we have plenty of delta V for landing. But yeah, there's probably some optimizations we can do to try and reach that 70K. It's just like we need just a tiny little bit more fuel. Like when we land at 60 kilometers, we have like 100 meters per second of delta V. Like it's that close on the margin. All right, we're looking good. We're starting to pitch up. Nice, look at that. We're pitching up. Aiming towards the pad. Yep, we're trying to bring it in. We might do a small overshoot here. It's actually looking okay. No, it's actually looking money is what it's actually looking like. And there's vertical. Okay, there's engine burn. Pushing it towards the pad. We're gonna be slightly off here. That's the trouble with linear control, is that it's not very good at dealing with different configurations or like different flight profiles. Oops. How did we never... What? Hold up. Oh, this is genuine. Oh. I was like, what? How did that happen? It's because we hit an error somewhere. PID is not callable. Oops. Oops, chat. Where? Not there, obviously. There. Hey, don't mind this. Now it's a missile, chat. Now it's a missile. Yeah. This needs to be .update. That would probably fix it. Look at it go. Does the missile know where it isn't? Not anymore, it doesn't. What's up, Stealthy? How are you? This is fine. All right, let's do the thing, chat. We got some control surfaces, right? We can totally steer this thing in. All right, look at it go. There we go, chat. Yeah. All right, what are we gonna aim for? We're gonna aim for this tree right there, chat. That's what we're gonna aim for. What? The tree shifted. That's not fair. We want that one right there. We want that one right there. Come on now. You can do it. Come on, DCX. Bring it over. Aiming for that one right there. Come on now. Come on. Almost there. No. Ah! Missed it by that much. All right, let's bring it back. Get to space. Yeah, exactly. Again, chat, where were y'all on the whole pair programming thing, all right? Where were y'all? Engineer using programming languages? Yes, absolutely. Depends on the engineer, though. It really said, never mind not landing today. That's true. They very much did. There we go. That should be fine. F5. All right. Let's do a thing at the place. And I want this. And I want some of this. And I want this. And let's try it again. But yeah, we use, like for me, I use Python mainly for simulations. And then Rust for some embedded system stuff. Bunker busted in. Indeed. Missed it by that much. Okay, there we go. We're in cruising altitude, or cruising up to altitude, I should say. Coast period. There we go. Okay, should be aligning itself towards the pad. Oh yeah. All right, doing its calculations. You can see right now we are moving towards the pad. We're pitching down pretty far, but our velocity controller is starting to help us pitch up. So how the two PIDs work right now is that they're both commanding pitch. And essentially the distance that we are away from the pad is commanding a certain pitch. And then our horizontal velocity, to regulate our horizontal velocity, we are pitching up. So the two PID outputs are actually being added together. Because we're kind of far away from the pad, that controller is actually calling us to pitch down. And but because we have a pretty high horizontal velocity, that's causing us to pitch up. So they're canceling each other out effectively. There we go, entering horizontal landing mode, entering burn mode, aiming towards the pad with our burn. Excellent. Pretty good, actually. Yep, we are aiming towards the pad with this burn, trying to move us closer. There it goes. Come on, baby. Entering vertical descent. Oh, okay, hold up. It's trying to get there. Oh! Chat. You know what? From what that showed me, better. We're getting there. I think this needs to be more like 5 or maybe like 4. Because what was happening there is that, you know what? Also, probably the control PID probably needs to be tuned. We were doing some like pretty wild swings, right? Which was changing our thrust vector very quickly. And because we had such a small horizontal velocity component, it was our horizontal velocity was getting swung around, which is why we were basically ended up chasing it, which is why we started to do the bottle top spin. So probably a couple things we could do. One, we can tune our horizontal velocity controller. So hvel controller dot update gains, and what are they right now? So right now they're 0.3. So let's do 0.1, 0.01, and 0.05. A little bit more derivative term in there as well to limit our overshoot. The reference coordinate system is wrong. That's also a possibility, but I'm not so certain of that yet, only because like you could see there, our actual horizontal velocity, our velocity vector was doing this around our compass here. So I think we ended up trying to chase it, but possibly it could be our reference coordinate system is incorrect as well. The rocket was tired indeed. I just want to try that first and see what happens. And then if that, we can probably do like else vessel dot auto pilot dot target pitch is going to equal to 90. That way, if we're not doing anything, or like if we're lower than this, then just point vertical, because that should be pretty low. Poor Brig, that flew pretty good. Heck yeah. Okay, well, we can at least see what that's going to do. But I think overall, everything should be good. I think. Let's try it again. What's up, Portable? How are you? So yeah, we tuned the PID a little bit, hopefully to have smaller, either that or slower, no, probably smaller outputs based on our horizontal velocity, since we're dealing with such low horizontal velocities at this point, really. Yeah. Trying to think of what else we could probably do. That's fine. Yeah, that's fine. Okay, let's try it again. Just as is. We changed our gains a little bit. I think we should be really fine. We'll check though, we'll check. No. Looking good. Ghost on up. There we go. Yep. Big overshoot this time because I was time warping, but that's fine. No worries. Okay, should enter hover and kick. There it goes. Not too shabby. There we go. We're getting there. We're tuning it. Oh my god, is that really happening as well? Son of a gun, chat. Again, y'all, what are y'all doing? We're every loop we're commanding 90, and then down here not doing 90. Oh, what? I mean, really? Come on, chat. Do better, all right? Well, let's just see kind of like what this happens. But that could have also been a problem. I like how close it's getting. We actually might want our vertical distance, our horizontal distance, to have a slightly larger effect. Either that, or we can have a bigger output here on our propulsive landing. Might also be good. We're doing pretty good though, all things considering. See, we actually, I think, are kind of doing it correctly, because you saw where the retrograde vector was. We were on the right side of the retrograde vector, but because it's spinning around so much, I'm just wondering, like, is it our... I don't think it is. What I actually might want to do next is try to limit on our descent, our actual aiming towards the pad, so we actually don't get too high of an offset in our horizontal velocity, and we can kind of get ourselves aligned and then let it go and see what it does. I'm just wondering, I want to confirm whether or not it is our reference frame. We're getting the wrong horizontal velocity vector or something like that, because it could very well be that, but it kind of seemed like we were aligning ourselves there. The other thing we can also do is actually output our horizontal velocity to see if we continue to make it lower. And we can also probably limit our angle from like plus or minus 10 to plus or minus 5 as well. Could probably be good. So let's do that. Let's first output print those things that we want to see. Let's take it and put it here. I think some of the good things to do would be this. Our velocity, our horizontal velocity would be good to check. I don't care about the distance pitch or the velocity pitch. I actually want our pitch input. Yeah. Because that'd be the output from the controller. Heading I don't really care about right now. Yeah, I think I want to see that, especially this one. Yeah. And then this, let's go to +5 and -5. And see what that does. Okay. Yeah. Stand by. That seems good. One second, I'm trying to figure something out here. Because we were always less than -10 when we could be as upward of -20, so why? Why is that? I think it just has something to do with the output, right? You know what, let's actually get rid of this, and I want to see how it performs with that. It'd be interesting. Okay, well, let's try it. I'd be super jazzed if you wanted to test out. All right, Lava. Let's see. Hello, Discord. Discord, where are you? There we go. Sweet. All right, that seems good. Ah, okay. Yep, fudge factor. It's kind of what we have as well. Ooh, you have a scale height. I'd definitely be interested in that. Is that in a loop or anything like that? 37 through 143 are coming out. Okay. Take a gander. Get that up. All right. There we go. Yeah, our altitude, or Apple Apps' estimator is doing pretty dang good. Looks like we'll be about 50 meters off our target. Okay, there we go. Enter hover. And kick over. There we are. Aiming towards the pad. That is good. Yep, pitch down 20. Horizontal velocity is increasing, so we're starting to pitch up. Good. That's our landing spot that we're aiming for. It's looking pretty good. Ah, I got you, Lava. Okay. Okay, looking good. Basically falling right down on it. Going vertical. Engine start, aiming towards the pad. We are commanding 9. Yeah. Oh, that's actually not bad. 7. Okay. It looks like we're on the opposite side, maybe? I wonder if I just need to switch. Where's A10? Hold up. We need the ATAN function. Direction, ATAN 2. I wonder if that needs to be 1, and that needs to be 0 to get the opposite direction. Yeah, we'll see. That actually might be the fix right there. All right, Lava, what you got here, bud? So this was sent over in Discord from Lava as part of our altitude estimator. Is it something that needs to be run continuously? Like in a while loop, or just once at the very beginning? Because we have this while loop where we're burning, right? And what's the output to this, or output from this, I should ask. Let's get it here real quick. Squirt. There we go. To calculate the drag, and you calculate the future. Okay. YX for A10, yeah, indeed. Okay, so this is what we got. So we have our scale height, 5600. That sounds right. Yep. For that, calculating our drag on the vehicle, basically estimating a drag loss, and calculating our altitude future. I guess every time you get new info, sweet. And that is what we'll do. Control cut. And then that needs to go here for predicting future apoapsis. But it doesn't need to be inside of its own for loop. Because it's not an integrator in that sense, a numerical integrator in that sense. So let's do that. And then I guess we will print out H future, right? Yeah. Yeah, I think that's what we can do. Should be easy enough. Sweet. Yeah, we can see what it does. Come on, KSP, you can do it. I believe in you. All right, so we updated the ATAN2 function. That is the big thing here, to actually see if that's going to work out. Hopefully. All right. Boop. All right, let's see what we got. So we're targeting 15 kilometers, I think. Needs to be before line 164. Well, what used to be line 164. So if you're talking about this one, then yeah. Oh, I see. I didn't realize you called it the same thing. I was actually just doing this to test it, and not have it actually be in control of the vehicle, if that makes sense. But are we updating H future? Yeah, we are updating H future. Okay, that's fine where it is. Yeah, we're printing it out. It's not necessarily in the control though. So we got it at 13. So it's the tweak, right? So it needs to be slightly less, at least at this altitude that we're going to, 92%. It seems like it works. It gets pretty close. It's just the tweak, right? That is the primary, the fudge factor, as you called it. The primary tuning parameter. Yeah, what's up, Captain Crash? How are you? That's good. There it goes, and kick over. Aim towards the pad. Perfect. Sweet. All right, so distance to pad, horizontal velocity, pitch required by according to our distance to the pad, and our pitch indicator according to our horizontal velocity vector, and this is our actual pitch angle, what we're actually commanding. So we're now basically pitching up because we're getting pretty fast here, but we're looking good. Very nice. Yeah, Lava. Yeah, it's just the the tweak. The tweak, the scalar factor there can be tweaked for different altitudes. Because what you can then do, right, is create a table of these, and based on your target altitude, after you launch a certain number of times, figure out what would be the best or most accurate. Okay, switching over. Looking pretty good. Not bad. Aha! It is our heading. I need to do the same rotation to our heading, because right now it looks like it's aiming over here, but I need it to be opposite because of our engines. It's basically acting as if the engines are like on the top or whatever, or like we're facing the direction of the engines. That's why. So I actually... Because we did that up here, right? Because it was basically the same exact thing. Yeah, we add 180 degrees, and then if heading is greater than 360, subtract 360. So it's going to be that, and then we can, I guess, just add it here, 180. And then if heading... Ooh, wait, if heading is less than 0, add 360, so it's not the exact same. No, but it should be fine. But now do I need to subtract it? Hold up. So it's now never going to be 0 or less than 0. So yes, now I need to do, if it's greater than 360, subtract 360, right? Because this is, ATAN 2 is bounded between negative 180 and positive 180, and now we're adding 180. So that will change the bounds. Oh, that should actually do the same thing, right? It should never go above 360. Yeah, should never go above 360. Okay, so this isn't even required then. Am I thinking about that right, chat? I think I am. Because right now it's basically saying we need to change our heading by 180 degrees. And so adding 180 degrees should be the right call here. And then because we add 180 degrees, we no longer need to check our bounds for compass heading because we are now within 0 and 360 by adding that 180 degrees. I think that's right. I think that's right. The simplest formula, indeed. Yeah. Indubitably. It works out. I mean, it works well. We're gonna test it again too. We just changed the fudge factor, as he called it. Speaking of the fudge factor, we lowered it, right? Which means that drag should have less. Oh no, don't we need to increase it? Drag should have more effect. Let me see, how do you implement that scalar? There it is, tweak. So times the scale height times the drag. So yeah, you're basically multiplying the drag, essentially the square root of the drag. And that's our drag loss. So by subtracting it, we're actually saying, yeah, so it actually needs to be the opposite. So let's go to 97. Let's go to 97%. We were originally at 95, so this should basically have us burn farther, burn through our desired target more. So pretty good. Cool. Lowering was right? Ah. Damn. I was thinking we wanted our drag loss to be higher. That we were burning longer to account for our drag. Well, we'll see. Oh, it was about the same. But yeah, you're right. I think, suppose so. Suppose so. Wait, how does this get implemented? Plus losses divided by that. Yeah, okay. Yeah. Yeah, I see. Indeed. Gotcha. There we go. All right. This is the one, chat. I can feel it. Knock on wood, Kappa, all that jazz. Okay. We're now moving towards the pad. Excellent. Pitching up. Looking good. Yeah, that's looking real good, actually. There we go, burn towards. Okay. I want to check this here. Did not actually seem to do what I was hoping it would. Guess I need to print my heading. Oh, also, probably, wait, where are we actually calculating our heading? We're calculating our heading here. You know what, maybe we actually don't need this. I'm wondering if our horizontal velocity is so low. Oh, that's why. I'm silly, chat. That is actually part of the problem, I think. Because we're printing out our distance to the pad, our horizontal velocity. And our horizontal velocity was lowering itself after that point. We came in with a pretty high velocity. It started slowing down. This was its pitch desired, so it's still slowing down. I think it might be right. Because we're starting off at 30 and then we're going -5 pitch and we're starting to slow down. So that's good. Do I have SciPy? No SciPy. Because we were lower than 4, so then this wasn't actually doing anything at this point. So it wasn't updating. You know, let's just have it greater than 0 to see, because I want it to actually be activating like all the time. Gosh, we're like so close, chat. Like truly. This is the last little thing that we need. Then I wonder, we gotta get our our boost back burn. Right, we're doing this in stages essentially. We have the ascent mostly figured out, except for terminal guidance on like the second stage. But the entire first stage is automatic. I'm talking about for launch vehicles, by the way. Then we need to figure out our boost back burn calculation, and then from there we could essentially use this, what we have here. Because the boost back burn should get us, depending on how well we can actually estimate everything and calculate everything, should get us to basically burn until we are intercepting the pad, essentially. I think the way to do that is to basically calculate our orbit, thinking that we're in an orbit, except we're going to have an intercept at ground level. And so I think we can basically propagate ourselves in time until our orbit intercepts, has an intercept on that line. It actually shouldn't be too difficult if I'm thinking about that correctly. So then we just burn, and then that should give us our point, right? For basically hitting the pad. And then we just need the guidance that we have, that we're working on now, to bring us in for the final landing. It's at least probably one way to do it, I think. All right, let's try this again. This time, hopefully it'll have it. You know what? Actually, hold up. I want it to enter landing mode much higher. So let's do it at like 280 degrees, ideally. Yeah, so we can actually kind of see what it's doing. We have more time to see what it's doing, so let's do that. Because now instead of basically coming to a hover slam 10 meters off the ground, we can actually see what's required a couple hundred meters off the ground, so we'll see what that does. All right, this is also with the new fudge factor. Uh, 0.9. Still seems to be a little off, but not super far off. Did like the exact same we're only gained 100 meters in our estimation here. Now why? Yeah, I'd have to dissect that and see why. Yeah, still currently heading to 15 kilometers. So I guess drag, because we're going to a much lower altitude, just has a way larger effect, which is, I mean, obvious, but that would have to be my guess. So yeah, we'll try it again when we're going up to 60 kilometers here soon. All right, let's see what we can do again. So now, ideally, we should enter our terminal landing descent mode when we're like a couple hundred meters off the ground. So ideally, we can really see what it's doing. Looking pretty good, though. That's working. That is working as intended. Mm-hmm. See, it looks like it's staying on the exact opposite side that it needs to. So we need our heading to be changed by 180 degrees. We can actually null out our horizontal velocity like that right there. So yeah, our heading, I think, is incorrect. I think our calculations are fine, but we're not aligning ourselves with the vehicle's body frame, essentially, because our engines are actually, we're basically pointing up, right? But our engines are pointing down, and we're basically acting as if we are pointing down, our control point. So I think that's why we need the 180 degree change, like I was originally thinking. Wait, do I actually still have that 180 degrees in there? Oh, I do. Hold up. I thought I had taken that out. Let's see. If I take out the 180 degrees, but then I need the I need this to be what it was actually, because it has to be bounded because it's a compass heading. So if this is less than 0, then we need to add 360, right? We're still adding 360, or is it we're adding 180? Because if it's negative 180, and we add 360, it's 180. Yeah, so it should only be 180. No, it should be 360. Yeah. Because negative 180 should be... Should it always be adding 360? This is going to be bounded. Son of a gun, chat. This is going to be bounded between this is going to be bounded between negative 180 and 180. So if we wanted to bound it between 0 and 360, and if it's less than 0, we should be adding 360. Because then that would make it a heading of... No, because then that would bound us... Well, if it's negative 1 and we add 360, then it goes... Yeah. No, that's right. I'm right. Yeah, because if it's essentially 0 and we're adding 360, then that goes around. Yeah, that's fine. That's fine. That should be correct. Yeah, it's 180, and then going down from there to 0 gets us the other side of the 360. Yeah, indeed. Yeah. Yeah, okay. Try it again. Okay. All right, sounds good, RJ. Sounds good. There we go. Yep, moving towards the pad, doing all the things that it should be doing. Excellent. I like that we got this set up. Like, this part works super well. We're aiming towards the pad. We're moving towards the pad. We're changing our pitch in order to maintain our downrange distance. We actually probably want to lower our horizontal velocity damper a little bit so we get closer to the pad. But overall, we're really quite good there, which is nice, because we get within 100 meters of the pad before we enter terminal descent. And there we go, switching around now. And then engine start, point towards the pad. Looking good. It's still on the opposite side. I just don't understand. Uh-oh. This is fine. So why is it still on the opposite side, chat? We are sure that it does changing it from Y and X to XY, does that flip us 180 degrees? for atan 2? What does that do? Or is that not that simple? Because atan 2 is bounded between negative 180 and 80. It's y over x. So if we give it x over y, is that changing that vector? That angle rather? Looks like it rolled 180 degrees at the end. I think that was because, yeah, I think that was because it was calculating a new heading. And so it was rolling to keep our zero roll angle with respect to that heading. Because within the autopilot that we're using in KRPC, roll, pitch, and yaw are all, well, actually, essentially roll and pitch are coupled with the heading because it's all relative to the heading. That'd be 90 degrees. Okay, so I'm just trying to think, right? We need it to be 180 degrees offset from here, but adding 180 degrees here is obviously not correct because that's what we had. If we're 180 degrees off of the heading that we should be, it should be just a matter of adding 180, right? Because if we add 180, right, then that bounds this to 0 and 360. Which means that we should no longer need this because it's already bounded between 0 and 360. Oh, negative. That's the opposite that I was thinking of. And then take off the 180 degrees from here. Let's try that. Yeah, thank you. Let's try that. Yeah. It should be negative y and negative x. Is that what you're saying? atan 2 negative and negative. Make that to essentially add 180 degrees. Yeah. Let me just look at it. Let me just look at it. It should be negative y, positive x. From what I can gather. Yeah, negative y, positive x. Yeah, quadrant 2, quadrant 3, yeah. And we'll see. We'll see how this goes. I think it's negative x positive, or negative y positive x. Looking at the graph. Yeah, we'll see. Right now we got both negative. Okay. Looking good. Come on, meow. There we go. Pitching up. So yeah, I think I also want to probably tune our horizontal velocity controller on this side as well. That way it has slightly less effect. Slightly though. It's doing pretty good, but I think it's over-regulating our pitch. Yeah, we could have this be like 2 or something. There it goes. That's doing pretty good though. So it should be over here. So it should be over here. That's not. It's continuously, yeah, it should be 180 degrees still. Why is it still 180 degrees though? Yeah, let's do negative y, positive x. Slightly frustrating, chat, slightly. And we are greater than 0 during that whole thing, right? Yeah, we are greater than 0 through that whole thing, so this should always be active. Never just this. And we were outputting, oh, we're still not outputting heading. I'm so silly. There we go. Let's also put output heading. Yeah. All right, let's see what that does. Alrighty. Let's see what that does. Just make landing pad bigger. Yeah. That sounds right. I mean, of course. Oh, we got to 14 kilometers that time. There we go. Oops. Alright, I should definitely not input any time warp while we're descending. That might be bad. But it's actually handling itself pretty well, right? We overshot and now it turned around and is heading back towards the pad. That's pretty good. Still the same. Why? Heading is 59 and 60 when it should be over here. Literally 180 degrees off. Heading, target, heading, heading. We just add 180 degrees here. I mean, seriously, I don't understand what is keeping this from following that. I mean, it could be our, I guess, our frame, our reference frame for our velocity vector. Because we're using basically an ECI coordinate frame. We're using a hybrid frame that's using the reference frame for position with respect to Kerbin, the rotation of the vessel with respect to the surface, and then also the velocity with respect to the body frame. Yeah, I'm not sure. But anyways, chat, the puppy now does need to go out. So I think that's a pretty good time to stop. We'll pick things back up here probably tomorrow to see if we can't finish this horizontal landing. And then we get into some Nuglin design and implementation in KSP and start working on the whole boost back landing stuff as well. That's the goal, chat. We'll see. But I'm out. Have a wonderful rest of your Sunday, chat. Hope you guys have a good Sunday wherever you may be, and hope to catch you guys back here later. All right, chat. So yeah, y'all have a good one.